So in this video, we will be talking about the Bohr's model of atom. Here, we will be discussing the basis of this model, the different postulates of the model, the drawbacks of the model, and all other related informations. So before starting the video, please do subscribe our channel and also like our video. So quantum mechanics, quantum physics, the theory of relativity, these all are some modern subjects that are almost confusing to everyone. But the concept of quantum mechanics or quantum physics was first used in the Bohr's model of atom. So before going into the detailed information about the Bohr's model, let us know about its discovery. So Bohr's model was proposed by Niels Bohr in 1913. So he modified the problems and limitations that were associated with the Rutherford's model of atom. Earlier in the Rutherford's model, Rutherford explained that in an atom, a nucleus is positively charged and is surrounded by electrons. So Rutherford said that in a nucleus, it was positively charged and around that nucleus there were electrons surrounding the nucleus. So Rutherford said that the electrons moved around in a predictable path called orbits. So these were called as orbits by Rutherford. But Bohr modified the Rutherford's model where he explained that electrons moved around in a fixed orbital cell. Furthermore, he explained that each orbital has a fixed energy levels. So later, Bohr said that in the nucleus, the electrons, so the electrons move in a fixed orbital cells. So this is the nucleus. And these are the orbital cells, the fixed orbital cells. And the electrons, they move in these fixed orbital shells. So Rutherford's model basically explained a nucleus of an atom, whereas the Bohr's model explained about the electrons as well as the different energy levels associated with it. So let us summarize the whole Bohr's atomic model as follows. So the Bohr's atomic model says that a small positively charged nucleus is surrounded by a negatively charged electron in fixed orbits. So these are the orbits, different orbits. So this is the nucleus, which has both the protons and the neutrons. These are the orbits. and this nucleus is surrounded by the electrons. So these are the electrons. So he concluded that the electrons will have more energy if it is located away from the nucleus, whereas the electrons will have less energy if it is located near the nucleus. So the electrons that are far away from the nucleus will have more energy. That means this electron which is away from the nucleus will have more energy, whereas this electron which is closer to the nucleus will have less energy. So this was the Bohr's model. Next, let us go to the postulates of the Bohr's model. So the first postulate says that electrons revolve around the nucleus in a fixed circular path termed as orbits or shells or energy levels. So the electrons so these are the electrons. So it says that the electrons revolve around the nucleus. So this is the nucleus in a fixed circular path. So this is a circular path. These two are the two circular paths, and these circular paths are termed as orbits or shells or energy levels. So the second postulate states that these orbits are termed as stationary orbits. So these orbits are stationary in nature. Stationary orbits. So these are stationary orbits. The third postulate is every circular orbit will have a certain amount of fixed energy, and these circular orbits were termed as orbital shells. So the electrons will not radiate energy as long as they continue to revolve around the nucleus in a fixed orbital shell. So the circular orbits, they have a certain amount of fixed energy. That is, a particular orbit will have a particular energy, and those circular orbits are termed as orbital shells. So we can write circular orbit will have fixed energy and these circular orbits are termed as orbital shells. And the electrons will not radiate any energy as long as they continue to revolve around the nucleus in the fixed orbital shells. Number 4 is the different energy levels are denoted by integers such as n equals to 1 or n equals to 2 or n equal to 3 and so on. So the energy levels are denoted by n equals to 1 or 2 or 3 or so. So these are called quantum numbers. So the range of quantum number may vary and begin from the lowest energy level to the highest energy level. So this n equals to 1 or n equal to 2, these are known as the quantum number. And the quantum number ranges from the lowest energy level, that is n equals to 1, to the highest energy level, that is it may be n equals to infinity. Okay. Then the fifth postulate is the different energy levels or orbits are represented in two ways. So these are the three different orbits or energy levels, and this can be represented in two ways. Either we can write 1, 2, 3, 4 or K, L, M, N shells. So this first orbit, that is the innermost orbit, can be represented as 1 or K. The second orbit can be represented as 2 or L. The third orbit can be represented as 3 or M, and so on. The lowest energy level of the electron is called the ground state. So since this is the lowest energy level, so this is known as the ground state. And the sixth postulate is that the change in energy occurs when an electron jumps from one energy level to another. Suppose in an atom, the electron moved from lower to higher energy level by acquiring the required energy. However, an electron loses energy when it moves from higher to lower energy level. Since we know that the energy level for a particular orbit or shell is fixed, but a change in energy can also occur when an electron, suppose these are the various levels, right? This is the M, L, and T. Suppose an electron is in the K shell. So if it jumps from K to M shell, then the energy will be required. And if an electron from the higher energy level, comes to a lower energy level, such as L, then energy will be released. Therefore, we can say that the first orbit or the K shell can accommodate a maximum of 2 electrons. The second orbit or the L shell can accommodate a maximum of 8 electrons. The third orbit or the M shell can accommodate a maximum of 18 electrons. The fourth orbit or the end shell can accommodate a maximum of 32 electrons. So the orbit continues to increase in a similar manner. Now we will learn the distribution of electrons in these orbits or the shells. So distribution of electrons in the different orbits or shells. So electron distribution of the various orbits or energy levels can be calculated by the formula twice n square, where n denotes the number of orbits. So in the first orbit or the K shell, the maximum number of electrons that can accommodate is equal to 2 into 1 square, that is 2. Therefore, a maximum of 2 electrons can accommodate in the first orbit of the K shell. So in second orbit or L shell, the maximum number of electrons that can accommodate is equals to 2 into 2 square, where this 2 is the orbit number or the number of orbit, that is equals to 8 electrons. So the third orbit can accommodate a maximum of 18 electrons, and the fourth orbit can accommodate a maximum of 32 electrons. So this was how we can distribute the electrons in the various orbits or shells. So at last we will learn the drawbacks of the Bohr's model. So the first drawback of Bohr's model is that it was unable to explain the spectra of atoms having more than one electron, number 2, it contradicts the Heisenberg's uncertainty principle, and number 3, it fails to explain the G-Man and Stark effect. So G-man effect is the splitting of spectral lines in the presence of magnetic field, whereas Stark effect is similar to the G-man effect except that it is produced in the presence of an external electrostatic field. So this is magnetic field and Stark effect is electric field. So thanks for watching the videos, and if you like the video, do subscribe the channel.